Hi. So we come to our third speaker for today. It's Pushkar Kumar of Synopsys, who's going to talk about faster TB development with automated code checks. Pushkar is an application engineer at Synopsys with 11 years experience in IP and SOC verification, related EDA technologies and custom support, and he's based in Reading. Over to you.
Thanks, Mike. Thanks, thank you for organizing this. Good afternoon, everyone. I'm Pushkar. As Mike said, I'm an application engineer at Synopsys. And I'll be talking today about writing code for test bench or RTL development and how automated code checks can aid in faster development. I'll be talking about the support that we might need that's missing now to check correctness of code while developing our test benches. Okay, so the much desired shift left in verification requires that advanced analysis and debug technologies be available to engineers from the earliest stages of the project. It is preferable that many classes of errors, especially the syntactical and structural errors, to be detected on the fly as designers code their RTL design and verification team develops the test bench and supporting environment. Even better if the engineers can receive the suggestions on how to fix these errors interactively as they type in their code on the fly. So some of us like using VI as a code editor. Some might use Emacs or VS Code. Well, these are wonderful editors, but the thing that is really missing about these tools today is that they don't really understand system Verilog. They don't understand the linting that should go on, or how the test bench structure is really put together. These tools do not use real rules to check the correctness of code. Let's take an example of Apple iOS development that is used for making iPhone apps. Developing for an iOS device requires Apple Xcode. Same with Microsoft Windows application development, which requires Visual Studio. The complexity of the software development requires more than just manipulating text today. System Verilog users similarly would want correct by construction code so that they can spend their time doing the development that needs to be done. And also with everyone adopting their own flows or tools to write code, it becomes harder and harder across the team to share the best practices. So code development can be done faster if we have some level of automated code checking while we are writing the code for test benches or RTL. There aren't many tools today which do test bench linting with a good understanding of system Verilog and UVM. We can avoid a lot of test bench errors if we have verification rule checking on the code as we type it. And with on-the-fly design rule checking, while coding DUT, we can also prevent a lot of issues which are typically uncovered during, say, synthesis or simulation, which saves a lot of time at later stages and ensures that downstream tools are more likely to work the first time we run. And an interactive development environment, say, such as Eclipse for software coding, with coding acceleration, code viewing and navigation, integration with version control, bug tracking, task management can also help improve productivity. So what are the test bench checks that we might like to have in our code editors today? This slide will present some of the important rules that we should be checking while writing our test bench code. The first one is rules to check the procedural code such as detecting dead code or unreachable code, or detection of time zero issues such as out of bounds access, unique case violations, or countersign evaluation at time zero, etc. Detecting null class access or virtual interface access, and checking for infinite loops or recursions, which are sometimes very difficult and time-consuming to debug. We can, a very common problem that many companies, teams, or projects have is migrating from UVM 1.1 to the latest IEEE standard. There are many small differences between these two versions of UVM code base, such as macros being consolidated or use cases that are slightly different now. Solutions to load up code using different versions of UVM and fixing migration issues all at once is highly desired rather than fixing issues one by one as they come. UVM being a complex methodology with a lot of macros, classes, APIs, having specific UVM rules that can be checked while we write code, can also help greatly in correcting non-compliant or incorrect code. We should also have rules to check method overrides and implementation inconsistencies or irregularities. It would also be great to have rules to check the system verilog assertions while writing the code rather than debugging later, which again can be a very tricky debug. Rules to check correctness of constraints with information such as inconsistent set of constraints will help saving a lot of debug time as well. We also must have checks for data type mismatches and for simulation performance rules such as say an unused clock, which can help in saving a lot of simulation cycles which may otherwise go undetected in a test bench. Similar to test bench checks, in this slide we'll see some important design rules, design check rules, which can save us a lot of time during our duty development or RTL development. We can have a pseudo synthesis checks while we write our code, such as existence of combinational loops or latches or ungated flops, etc. We can have checks for clock and reset related issues as well. Checks for drives or load violations. Procedural code analysis checks similar to what we had in the test bench checks, which makes more sense in design checks than test benches. Width mismatches, rules to check width mismatches and other data type mismatches can be helpful as well in saving time if they are caught at the code development time. Similarly, simulation performance rules, such as the one I said earlier for, say, an unused clock, can be more useful if they are detected early while writing RTL. So what's the solution? Obviously, we have seen thus far the problem that we have with current code development solutions and some checks that would help accelerate the code development process. But how to do it? Of course, companies can have project-wide or company-wide methodology guidance teams which can implement automated checks or coding guidelines and enforce for all code check-ins probably. This can be done, but it's probably a big ask to implement so many checks. We, as an EDA company, keep trying to come up with solutions to accelerate verification process. One such solution that Synopsys has added to the design and verification scenario in recent times is Euclid. This is not a marketing slide, but Euclid is an IDE that similar to Eclipse for software development, that enables correct by construction, design, and test bench coding with a very good understanding of system Verilog, UVM, and structure of code. It has a high performance engine for design and test bench for complete elaboration, design resolution, and pseudo synthesis. It has an advanced linter for deeper checks and lint rules for simulation performance, emulation compliance, and synthesis, and more. Moreover, it can be, it has an advanced mechanism for integration with other EDA flows and can save time with downstream EDA tools. For more on Euclid, you can go to Solnet and follow the link for more, or just get in touch with us. Thanks, Mike. That's my presentation. Any questions you take?
Okay, Sarah?
Hello, hi Mike. Yes, we can hear you now. You dropped out for a moment.
Okay. Yes, no, thank you. I think I'm still on mute a bit there. Yes, so thank you, Gar, for your talk. We have a couple of questions. The first one is, how big a code base can Euclid handle? How big a code base do you need?
It can handle very big SOC codes. It does not depend on Euclid, really. It depends on the machine that you are running it on. It takes its capability from the machine. So.
Okay, so it's much more dependent on the machine rather than Euclid itself. So another question is that people are currently using Eclipse and the System Verilog Editor plugin. So what advantage would they have going to Euclid above the Eclipse and the plugin?
The first one is test bench linting that not many tools do. And the plugins we have in Euclid, we have a plugin for Emacs, VI, any code editor that you are currently using. So you don't have to get accustomed to a newer editor per se. You can use all of them in Euclid. And it does a lot of other stuff, such as pseudo synthesis, design linting, or test bench linting, which I talked about earlier.
Okay, and another one is that people who have used this type of environment, Lint, before, say that there's quite a lot of false errors or false negatives. How do you stop the noise and make sure that you reduce the noise to signal ratio on the types of information you're getting back from the tool?
Okay, so the beauty about Euclid is that you can suppress the noise that you see. I mean, something that is not relevant to you. You can suppress it for project-wide. You can have your own custom rules as well. So you can set it up according to the project needs or individual needs. And if you think there's a noise, you can suppress it forever. We won't see the noise.
Okay. And is there any support to reduce complexity rather than just give you feedback on the code you write? So you seem to be automating error detection, but can you automate complexity reduction as well?
Complexity reduction, as in Mike?
Well, so for example, there may be nested loops that you say try to reduce this nested loop, try to reduce these. There's
yes.
psychochrometric metrics that you may measure and suggest that you try reduce those complexity metrics.
Yes, so we have a lot of rules that do that for you. So the thing that you said, like for detecting loops, we have rules to detect loops that might occur at the simulation time. Yes, and you can define your own custom rules as well if you think that it gives you a very easy way to define your own rules for checking something that Euclid might not have currently. Or you can just suggest us and we will try to add those rules as well.
Okay, there's a few more questions, but we'll just take the fight, just one more, and we may put some more to you on email. How hard or easy is it to set this up? So, for example, can Euclid take parameters or arguments?
It can take parameters or arguments. So basically, the setup process. I won't go in much detail about that, but you can whatever parameters you want you can pass through a CUD file that you make during the project setup. The project setup is very similar to Eclipse, and it's actually based on Eclipse platform. So it's very similar. It's not really complex, and you can pass all the parameters or whatever you want to in your CUD file, and it will take.
Okay, thank you very much, Pushkar, for your talk. Okay, and we'll move to the next speaker. Thank you.
Thank you.
Thank you, Pushkar. Much appreciated.